let me ask you a very basic question here. So when you talk about a tree, then there is a very, very important property of tree that you should always remember. Let's say you have got 2, 7, 1, 3, 5. Is this a tree? Yes or no? Cycle or two parents. Very good. So when you look at this thing, it has got two parents, or in other words, you can say there is a cycle, right? Tree is an acyclic graph. Keep it in your mind. In tree, there cannot be any cycle at all. If cycle is present, then it's no longer a tree. You can call it a graph, because in graph you can have cycle, you cannot have cycle. So graph is a superset of trees. Okay, every tree is a graph, but the reverse is not true. Now, this is a very important point, and based on that, I'll ask you a question. Let's say there are n nodes, like here 1, 2, 3, 4, 5. 5 nodes are there. Then if there are n nodes, then how many edges would be there? Can you think of that? N minus 1, right? You can see that is happening here also. Like here, the number of nodes is 1, 2, 3, 4, 5, and the number of edges is 1, 2, 3, 4 edges. But it's not a mere I would say, coincidence. It can be very easily seen why this is the case. So tell me, if you have a tree which just has one node, and that node is, let's say, 2, it just has a root and it does not have anything else, then I can say here the number of nodes is 1 and number of edges is 0. Now, let's say you want to introduce an edge. Can you introduce that edge over here without introducing a new node? I'll repeat my question. Can you introduce an edge over here without introducing a new node? The answer is no. Some of you might be saying, hey, how about doing like this? I would say if you do like this, if you make a pointer point to this thing only, then that will be case of a cycle, which is not allowed. So if I want to introduce a new edge, I need a new node. Let's call that 3. And in this situation, what has happened? So see what I'm saying. If you want to introduce an edge, that means if you want to do a +1 here, you want to do a +1 here also. For every new edge that you want to introduce a new node. And now I'll move on. Now, let's say you want to introduce one more new edge over here. Can you introduce a new edge without introducing a new node again in this existing tree? Let us try doing that. You can say that, hey, how about this edge? Again, there is a cycle. That is not allowed. Any other option that you have? 3 to 3, again cycle. 2 to 2, again cycle. You can't do that. So if you want to introduce a new edge, you need to have a new node. So that new node could be 4. And you can either directly link this 2 to 4, or you can link this 3 to 4. That is up to you. That is up to you. The structure of the result tree will be different. But the only point is that if you have introduced this, you introduced that also. Similarly, again, if you want to introduce a new edge, you have to introduce a new node, because if, let's say, you introduce this edge, there will be a cycle. So if you want to prevent that cycle and yet introduce a new edge, you have to have a new node. So this 5 could have been brought here also. That is up to you. And this 5 could have been brought there also. That's up to you. So what is happening here is that the initial difference between n and e was 1. And now when you are doing a +1 here, you are doing a +1 here also. When you are doing a +1 here, you are doing a +1 here also. So the difference between node and edge will be of 1 unit. And it will continue to be like that. Because of this reason, I can say that number of edges will be equals to n minus 1, where n is the number of nodes. This is a very important property of trees. And because of this property, there are no cycles. Okay, let me ask you another question. Let's say there is a big tree like that. I'm going to ask you a very simple question. How many paths are there from 9 to 1? You are at this city right now and you want to go to this city. How many paths do you have leading you from this to that? There will be only one path. If you want to go from here to here, of course, how you can travel? You can travel via edges. Just imagine that these edges are like roads which are connecting different cities. So you can go from here to here, here to here, here to here, and here to here. There is no other way. Find me anyway. There is no other way. Why? Why does this happen? Because there are no cycles. Because there are no cycles. And let me tell you why this is a consequence of no cycles. Because if, let's say, there are two nodes, let's call them N1 and N2. These nodes are part of a very big tree. I have not drawn the entire tree. Now, let's say there is some kind of path from here to here. And then you are saying that, hey, there is yet another path also from here to here. That means there is a cycle. There are two cities. There is one road from N1 to N2, and there is another road also from N1 to N2. That means there will be a cycle. And because there are no cycles, it means there will be one and only one unique path between any two pair of nodes that you choose. Cool. So these were some very, very basic information that I wanted to share about trees.